We present Fogshop, a new method for real-time design and rendering of inhomogeneous, single-scattering media. We model inhomogeneous media like smoke and fog as a sum of Gaussians. Our new analytic approximation to the airlight integral captures single-scattering effects in real time. All video clips are captured in real time on a PC with an NVIDIA GeForce 8800 GTX graphics card. Note that video compression has introduced some visual artifacts. The first demo shows inhomogeneous airlight in an indoor scene. We begin with clear air. Next, we show homogeneous fog rendered using a method introduced at SIGGRAPH 2005. Our new method is able to render inhomogeneous media like the mist pouring out of a gargoyle's mouth in real time. Simple volume rendering techniques like density blending attenuate the background but ignore realistic scattering effects. Notice the loss of shadows and haloing, especially around the gargoyle's mouth. Ray tracing accurately simulates all effects, but is several orders of magnitude too slow for real-time performance. As you can see in this side-by-side comparison, our approximation matches the offline rendered results very faithfully. We can also add noise to convey the irregularity of real fog and smoke. The user can change the viewpoint and lighting in real time. The top left corner shows rendering statistics, including rendering rate and the number of Gaussians. This scene is rendered at about 100 FPS. Our rendering method also allows environmental lighting and pre-computed radiance transfer. Here is a city immersed in inhomogeneous fog. The scene is illuminated by an environment map and captures soft shadows using PRT. Our model also includes the media effect on surface reflectance as well as its direct appearance. Here we see two teapots of diffuse material illuminated by a point light source. The steam emitted from the teapot on the left scatters light, which affects the appearance of the teapot on the right. Notice the softening in the shading and the steam's shadow. To highlight the surface reflectance effects, we turn the fog off and back on. Now we change the BRDF to a Phong model. Notice the softening of specular highlights due to the steam. Fog off, fog on. We can also handle low-frequency environmental lighting. Fog off, fog on. In this example of a motorcycle in a foggy forest, we combine inhomogeneous scattering with PRT effects. The flowing fog is produced by a particle-based simulation. You can clearly see the varying blur of the distant environment due to the patchy fog. Also notice the effect of the local fog density on surface reflectance. Based on this real-time rendering engine, we've developed a system called Fogshop for interactive design of inhomogeneous media. We begin with a simple terrain scene. The user chooses the paintbrush tool and specifies a plane on which to project fog strokes. Fog can also be erased. Grouping strokes together allows them to be manipulated simultaneously. The drawn strokes look too regular, but the Disturb tool can be used to introduce random perturbations. After some minor adjustment, the user has created a realistic, foggy environment. To further enhance the realism, we add a homogeneous term and animated noise. The airbrush tool can create a foggy area or a foggy version of an existing 3D shape. It emits Gaussian particles that bounce off surfaces in the scene. The particles rapidly diffuse out to fill any open space. When the user stops the airbrush, particle movement is frozen, resulting in a foggy region. The system can also import animation sequences. Here we import a steam sequence which was computed offline. Note the air light and shadowing effect of the imported steam. We can also move the light source and camera on the fly. This is very useful for previewing and interacting with high-quality production content. We may also import animated objects to create some interesting effects. In this final scene, 4 ghostly humanoids tumble inside the Cornell box. Thank you.